Hello everyone. So in this video we will calculate input impedance seen from this node A. Okay. So they have given channel length modulation is 0. So output impedance of each transistor will be infinite. Okay. So let's solve this question. So I have copied the same circuit. Now to calculate input impedance, we know that we open circuit the independent current sources and small signal grounded will be voltage sources. Okay. And we will apply a test voltage here, and we measure this test current, and Zin will be Vt by It. Okay, so this voltage is also Vt. Since output impedance of each transistor is infinite, so this current will be only Gm on into, suppose this voltage is Vgs2. At present we don't know what is Vgs2, so we will just assume. So this current will be Gm1 into Vgs2. Okay, and this current will be Gm1 into Vt. Okay, so what will be the this current It? It will be only Gm1 into Vgs2. Okay, so Zin will be Gm1 Vt by It. So it will be Vt divided by Gm1 into Vgs2. So now we have to find this Vgs2 in terms of Gms. Okay, so for that we will apply a KCL here. So if this downward current is Gm1 Vt, so upward current will be minus Gm1 into Vt, and this voltage will be Vgs3 equal to Vgs3 equal to Vgs2. Okay, so this same voltage is Vgs3 and Vgs3 equal to Vds3. So if we apply here a current division, okay, so what will be the current flowing through upward, and what will be the this one? So this current will be this voltage divided by 1 by SC1. So this will be Vgs3 divided by SC1. And what will be the upward current? Upward current will be simply, this is Im3. Okay, so that will be minus Gm1 into Vt and impedance ratios. Okay, so that will be 1 by SC1 divided by 1 by SC1 plus 1 by Gm3. Okay, so this current will be this Gm1 Vt current will be divided in both impedance, so that will be minus Gm1 Vt 1 by SC1 divided by 1 by SC1 plus 1 by Gm3. This current division. Now what will be the Vgs3? Vgs3 will be Im3 into 1 by Gm3. Okay, if this is diode connected, so I can replace this with the 1 by Gm3. Okay, so that will be 1 by Gm3 impedance. Okay, so now I know this current, and I know this impedance, so I can find out this voltage. So now let's put, and this Vgs3 equal to Vgs2 also. So this will be minus Gm1 into Vt into, this will be 1 by SC1 divided by 1 by SC1 plus 1 by Gm3 into 1 by gm3. Okay, so after solving, we will get minus gm1 into vt into, so gm3 will be cancel out, and sc1 also will cancel out, so it will only, we will get 1 by sc1 plus gm3. Okay, now we will put this vgs2 value in here. We will put in this equation, so that is Zn equal to vt divided by gm1. So Zn equal to vt divided by gm1 into vgs2, so that will be vt divided by gm1 into this current is this voltage is minus gm1 into vt into 1 by sc1 plus gm3. Okay, so this vt will be cancel out, and that will be minus sc1 plus gm3 divided by, okay, this one is gm2, so gm1 into gm2. So this is our input impedance looking from that node. Now we will assume gm1 equal to gm2 equal to gm3. Okay, so Zin will be minus sc1 plus gm, so the, and this will be gm square. Okay, suppose it's gm. Now this will be minus 1 by gm and minus s into c1 divided by gm square. Now if we will compare with the complex impedance r plus j omega l, okay, so here we can see that our input impedance is a negative input impedance, where the negative resistance is 1 by gm and negative l will be c1 divided by gm square. Okay, so this is our final input impedance. So this is negative input impedance when we look from this node. So there are many other examples of negative impedance we can use to tune our pole or delay, rise, anything, time domain or frequency domain. Okay, so please let me know if you find any wrong analysis. Okay, so okay, bye, thank you.